Hello everyone, I am Mayank and welcome to Simplilearn. Today we will take you through a hands-off lab demo of how we can use deep learning models for image classification using CNN. For amazing video like this, subscribe to our YouTube channel and press the bell icon to stay updated. In today's session, we will discuss what deep learning is, and moving ahead we will cover what is neural network, and in the end we will do a hands-off lab demo of flower image classification using CNN. So what is deep learning? Deep learning is a subset of machine learning that deals with algorithm inspired by the structure and function of the brain, and which is a part of artificial intelligence AI. Deep learning is widely used to make weather predictions about rain, earthquakes, and tsunamis. It helps in taking the necessary precautions. With deep learning, machine can comprehend the speech and provide the required output. It enables the machines to recognize people and objects in the images fed to it. Deep learning models also help advertisers leverage data to perform real-time bidding and target display advertising. So what is neural network? To understand how an artificial neuron works, we should first understand how a biological neuron works. So this is one of a biological neuron. So dendrites. These receive information or signals from other neurons that get connected to it. The second one is cell body. Information processing happens in a cell body. These take in all the information coming from the different dendrites and process that information. The last one is axon. It sends the output signals to other neuron for the flow of information. Here each of the flank is connected to the dendrite or the hairs on the next one. Now let's see a neural network. So this image shows an ANN. Okay. So the network starts with an input layer that receives input in data form. The lines connected to the hidden layers are called weights, and they add upon the hidden layers. Each dot in the hidden layer processes the inputs, and it puts on output into the next hidden layer, and lastly into the output layer. So here input to a neuron is known as input layer, and the actual neuron is called hidden layer, and the output to the next neuron is called output layer. A neural network is a system of hardware or software patterned after the operation of neurons. In the human brain, neural network, also called artificial neural network, are a means of achieving deep learning. So this is a Python kernel file. Okay. So here I will change the name deep learning with Python. Here we will do flower recognition using CNN. Okay. So first what I will do, I will import OS, and here I will write print os.list directory, then c slash users slash 09375 slash desktop. This is the path of that folder where I have put the images class. Okay, so let's run it. Yeah, so we have 5 categories in flowers like daisy, dandelion, rose, sunflower, and tulip. Okay, I will provide you the zip file of this dataset. So now import some major libraries. So here I will write import warnings, then warnings dot filter warnings, then always. Okay, these are just the warnings. When warnings come, it will ignore or it will always. Warnings, then here I will write ignore. Okay, then let's import some libraries for data visualization and manipulation. So here I will write import numpy as np, then import pandas as pd, my bad, import pandas as pd, then import matplotlib dot pyplot as plt, then from matplotlib import style. Don't worry, we will discuss each of the library. Then import seaborn as SNS. So what is NumPy? This one, NumPy. So NumPy is a Python library used for working with arrays. It also has a function for working in the domain of linear algebra and matrices. It is an open source, means free project, and you can use it freely. NumPy stands for numerical Python. And the second one is Pandas. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. Then the third one is Matplotlib. So for Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it represents a strong open source substitute for MATLAB. The APIs, application programming interfaces for Matplotlib, allows programmers to incorporate graphs to GUI applications. Okay, so Matplotlib import style or as PLT. Why we are writing as PLT, as PT, as NP? Because we don't have to write again and again the long sentence, the matplotlib.pyplot. Okay, we can import using short name PLT. Then fourth one is import seaborn. So seaborn is a Python data visualization library based on Matplotlib. It provides a high level interface for drawing attractive and informative statistical graph. For a brief introduction to the ideas behind the library, you can read the introductory notes or the paper from the website. Okay. So now let's set Matplotlib to inline and display graph below the corresponding cell for the corresponding cell. So for that I will write here %matplotlib inline. Okay. Then here I will write style dot use. This is one of the style. So here I will write 538. Okay. Then SNS dot set style equals to white grid comma color quotes equals to true. Okay, let's import some major libraries for model selection. So for that I will write here from sklearn dot model selection import train test split. Okay, then I will add from sklearn dot model selection import kfold. Then here from sklearn dot model, sorry, here I will add matrices matrix. Then import accuracy score comma precision score comma recall score comma confusion matrix comma ROC curve comma ROC. Okay, then here I can import ROC AUC curve not score. So now we will import some more, like from sklearn dot model selection import grid search CV. Then from sklearn dot preprocessing import label encoder. So what is train test split? Okay, this sklearn model selection train test split. So train test split to getting training and test sets. This control the size of subset with the parameter train size and test size. So determine the randomness of your splits with the random state parameter. Obtain specified splits with the stratified matter. Okay, then k-fold. K-fold is again a validation technique in which we split the data into k subsets and the holdout method is repeated k times, where each of the k subsets are used as a test and other k1 subset are used for the training purpose. This accuracy score, precision score, recall score, confusion matrix, ROC curve and ROC accuracy curve. So these all are for the accuracy, to check the accuracy, what will the precision score, and the ROC curve graph for making graphs and all. Okay, these are for metrics. Then grid search CV. So grid search CV is a technique for finding the optimal parameter values from a given set of parameters in a grid. It is essentially a cross validation technique. So the model as well as the parameter must be entered. So this is after extracting the best parameter values, the prediction are made. Okay, so this label encoder. So label encoding is a popular encoding technique for like handling categorical values, okay, or variables you can say. So in this technique or method, you can say each label is assigned a unique integer based on alphabetical order. Okay, so now for pre-processing I will import something. So here I will write from ks dot utils not pre-processing dot image import image data generator. Okay, yeah. So this is for the pre-processing of the image. So image data generator, what does it? Allows your model to receive new variation of the images at each epoch. Okay, so but do you remember that it only returns the transform images and does not add it to the set of images that you have, like for in our data set. Okay, just it is used for the transform in image. Now let's import some deep learning libraries. So here I will write from keras import backend as k. Okay, then another one is from keras dot models import sequential. Then from keras dot layers import pens. Okay, let's write from keras dot optimizers import adam sgd These all are the optimizers. ADA grad, comma, ADA, ADE, ADA delta. Okay, then last one is RMS Pro. Then from keras dot utilist import to categorical. Okay, so keras is a model level library providing high level building blocks for developing deep learning models. It does not handle itself low level operations such as like tensor products or convolutionals and so on, and this sequential. Okay, so sequential, the core idea of sequential API is simply arranging the keras layers in a sequential order, and so it is also called sequential API. Like most of the ANN also has layers in sequential order, and the data flows from one layer to another layer in the given order until the data finally reaches the output layer. And this dense. So keras dense layer is a layer that contains all the neurons that are deeply connected within themselves. This means that every neuron in the dense layer takes the input from all the other neurons of the previous layer. So we can add as many as dense layer as required. So dense is the one of the most commonly used layers in deep learning. And these optimizers, ADAM, SGD, ADA grad, ADA delta. So optimizers are classes or methods used to change the attributes of your machine or deep learning model, such as weight and learning rate, in order to reduce the losses. So optimizer helps to get result faster. Then this keras.utilist. So keras utilist to categorical function will return the binary value matrix which contains the values either 0 or 1. It contains an equal number of rows from the length of the input vector and column number which was equal to the class number which we defined in our code. Okay, so now let's import for CNN. So here I will write from keras dot layers import dropout flatten activation, and then from keras dot layers import conv2d, then max pooling, max pooling 2d, then patch normalization. Okay, so these are some more layers for the CNN, for particularly CNN. Then import TensorFlow as TF, then import random as RM. Then random is used for finding the random value. Then let's specifically for manipulating zipped images and getting numpy arrays of pixel value of images. Let's import that. So here I will write import CV2, then from TQDM import TQDM. Okay, then I will write import OS spaces, then from random import shuffle, then from zip file, okay, import zip file, then from PIL import image. So TensorFlow is an end-to-end open source platform for machine learning and deep learning. TensorFlow is a rich system for managing all aspects of machine learning system. However, this class focuses on using a particular TensorFlow API to develop and train machine learning models. Okay, train or test. So TQDM, it means like progress, and it is used to create a smart progress bar for the loops. Okay, now let's run this and see any error. Okay, there is one error. Grid search CV. Where is that grid search CV? Okay, S will be capital here. Okay, A processing. Maybe processing spelling is wrong, I guess. It's pre-processing. See, pre-processing. Okay, this is the spelling mistake, the minor spelling mistakes. Okay, here keras dot optimizers import Adam. So what's cannot import name ADA delta. Why? Because A should be capital here. A will be capital here. Okay. Now module name keras dot utils. Okay. It's utils. One more, the last one I guess so. Cannot import name zip file. Zip file, import zip file. Okay, these are some spelling mistakes you can say while importing. So now what we will do next, we will prepare the data and make the functions to get the training and validation set from the images. Okay, so here I will write x equals to blank array and z equals to blank array. Okay, then image size equals to 32. Then we will import all the because we have one particular folder named flowers, and on that we have 4 folder or 5 folder, like with one daisy, one sunflower, one tulip, one dandelion, one rose. Okay, so we have to import each of folder one by one. So here I will write flower, daisy from directory. Okay, and the directory is, I can copy from here. Okay, and paste it here. then I will write here Daisy. Okay, so don't worry, I will provide you the zip file drive link. Okay, you can check from the description box below. And here I will write flower, sunflower directory equals to, then here I will write sunflower. Okay, then here I will write flower, tulip directory equals to tulip. Okay, say tulip, sunflower, daisy are my folder names. So here I will write flower, then the directory equals to, here I will write dandelion. Then flower, rose directory equals to, okay, then rose. Okay, so now let's create function assigning label to image and flower type. Okay, then I will write here return flower type. Then what I will do here, I will import some OS, FN match and make train data. Okay, so I will write here import FN match, then I will write import OS, then def making function make train data, then flower type, comma directory for image in tqdm. For the loop I said os.list directory, list directory from dir. Okay, then here I will write if fn match dot fn match image start.jpg, like anything .jpg, then label equals to assign label to image of flower type. Okay, then path equals to os.path dot join directory images, then image equals to cv2 dot imread path comma cv2 dot imread color. Okay, then I will write here image equals to cv2 dot resize, cv2 is OpenCV file library, image comma img size comma img size. Okay, then here I will write x dot append these x and z, x dot append np dot array image, then X is capital there, z dot append str label, string label. Okay, so now let's run it. Yeah, it's cool. So here we will check the all the length of the training data set for particular daisy, that sunflower roll. So here I will like make train data, then daisy comma flower daisy directory. Okay, then I will print the length of like how many photos are there. So as you can see, there are total 764. So now like this we'll check for all. So here let me copy this and paste this here. Here I will write rows, and here I will write rows, then run it. So rows has 1584. Okay, rows like this. So it's flower rows. So now we'll check for sunflower like this only. Sunflower, here we'll write sunflower. Okay, 3065. Then here I will write for tulip, tulip. So they are 44049. Then last one, dandelion. Dandelion, and here I have to write D and DI. Okay. So first let me tell you about the dataset. So this dataset contains like 4242 images of flowers. Okay, 4242. So that data collection is based on the data Flickr or Google Images we took, or Y-index images, and you can use this dataset to recognize plants from the photo. And the picture are divided into five classes like chameleon, tulips, rose, sunflower, and dandelion. And for each class there are about 800 photos. Okay, not like all 800, but 800 photos. Like photos are not that much high resolution, about 320 into 240 pixels are there. So photos are not reduced to a single size, they have different proportion. Okay, so what I will do, I will give space. Now let's visualize some random images. Okay, so here I will write figure comma ax equals to plt dot subplots, then 5,2, then figure dot set size inches 15,15, then for I in range 5, then for j in range 2, like 5 or 2. Okay, 10 images will come. Then what I will write, then L equals to rn dot random input 0 comma length set. Okay, then ax I comma j dot im show xl ax I comma j dot set title, then flower plus z l. Okay, then plt dot right layout. This is one of the layout of showing photos. Okay, let's run it. So these are some random image of sunflower, that rose. So I already said you these pictures are not that high quality. Okay, that flower, rose is there, then tulip. So moving forward, let's label encoding with the y arrays, like daisy, rose, like daisy equals to 0, rose equals to 1, then 1 out encoding. So for that we'll write here L equals to label encoder then y equals to le dot fit transform z. Okay, then y equals to categorical y comma 5, then x equals to np dot array x, then x equals to x by 255. Okay, there is no y comma 5. X should be capital. Yeah, so now what we will do, we will split into training and testing validation sets. Okay, for that I will write x train comma x test comma y train comma y test equals to train test split. We already discussed what is train test split, x comma y comma test size equals to 0.25 comma random state equals to 42. Okay, so now let's set the random seeds. So for that I will write np dot random dot seed (42), then rn dot seed is again 42, then tf dot random dot set seed 42. Okay, what we will do now, we will do modeling. We will build a convert net model. Convert net means CNN model. So for that I will write here like model equals to sequential. Okay, then model dot add connet 2D, then filters equals to 128, then kernel size equals to 2,2, then padding will be same, comma activation equals to ReLU layer, then input shape equals to input shape equals to 32, 32, 3. Then here I will write model dot add max pooling 2D, then pool size equals to 2,2. Then I will write model dot add flatten then model dot add dense. Okay, D will be capital here, then 512. These all are for the layers. Then model dot add activation, that ReLU, then model dot add dense 5, comma activation equals to softmax. Okay, then let me run it. Convert to D. D will be capital. Okay, convert to D dot is the kernel size. Yeah, it's running. So now what I will do, using a ln earlier, we will set the batch side, we will set the epochs, and we will do the callbacks or not. Okay, so for that I will write batch size equals to 45, then epochs will be 10, then from keras dot callbacks import reduce LR on plateau. TEAU. Okay, then I will add red LR equals to reduce LR on plateau, then we'll monitor equals to validation score or accuracy, you can say, comma patience equals to 3, comma verbose equals to 1, comma factor equals to 0.1. Okay, so moving forward, what we will do the data augmentation to prevent overfitting. So now let's do the data augmentation. For that I will write here data gen equals to image data generator then here I will write feature wise center equals to false. So what this line will do, like set input mean to 0 over the data set. Okay, then I will write sample wise center equals to false. Now this set each sample mean to 0. Then I will write here feature wise center equals to false. So what it will do, no, it's feature wise. I will write standard normalization equals to false. So it divides input by standardization of the dataset. Okay, then sample wise standard normalization equals to false. Then it divide each input by its standardization this time. Then I will write here let's see a widening equals to false. Applies ZCA widening, then rotation range and rotation range equals to 10. It will randomly rotate images in the range like degrees 0 to 180. Okay, then zoom range equals to 0.1. This is for randomly zooming image. Then width shift range equals to 0.2. Then what it will do, it will randomly shift images horizontally like fraction of total width. Then height shift image range equals to 0.2. It is for randomly shift image vertically like fraction of total height. And this horizontal flip equals to true for randomly flipping images. This is for vertical equals to vertical, no, false. Okay, then data gen dot fit extreme. Some error is there. It is like width shift range 0.2. Okay, so let's debug this error. So let's run this again. Yeah, it's gone. So now what we will do, we will compile the keras model and see the summary. For that I will write here model dot compile this optimizer. We already know what are the optimizer. Equals to adam lr equals to 0.001. Okay, then loss equals to categorical cross entropy comma matrix equals to accuracy. Okay, let's run this. First let me give some spaces. Yeah, so here let's see the model summary. So as you can see here, the layer types like con 2D or max pooling 2D. So output shape is 32, 32, 128 and the parameters are given is 1664. Flatten is again the layer, dense is again the layer. Okay, so total parameter use 16, this much, and the trainable parameters are this. Okay, so moving forward, let's do the fitting on the training set and making prediction on the validation set. Okay, so let's write history equals to model dot fit generator data gen dot flow x train comma y train comma batch size equals to batch size. Okay, comma epochs equals to epochs comma validation data equals to x test comma y test, then comma verbose equals to 1 comma steps per epoch equals to x train dot shape 0 batch size. Okay, so let's run this. So it will take time, like it will run till 10 epochs of 85. Okay, from this we can get the accuracy for the validation. So I hope you understand till here. If you have any question regarding machine learning, deep learning, Python, you can comment or you can check our course from the description box below. It will take a little bit of time. So after this we will save this model, and from TensorFlow we import. Then we will do some model performance, evaluate model performance. After that we will recreate the exact same model, like including its weight and the optimizer. Then at the last we will visualize our correctly classified flower images predicted one. Okay, 5 are done, 5 more are remaining. Okay, like 3 more. If you have any problem in understanding the code, you can comment down below, or don't forget to check the course from the description box below. Okay, AI/ML courses. The last one is remaining. What we will do, we will save this model into Kaggle only. Okay, so here I will write model dot save to Kaggle working model 12.h5. Okay, this time accuracy came, validation accuracy 6442, 0.6442, accuracy is 66. Okay, so now from TensorFlow import keras, then model equals to keras dot models dot load model Kaggle working model 12.h5. Here I will do the save. I will save the model to the disk and load model from the disk. So let me write the code for that and get back to you. So saved model to disk and loaded model from disk. So now let's evaluate the model performance. Okay, for that I will give some space for better visual. So here we will plot plt.plot history dot history of loss. Okay, then plt.plot history dot history, validation loss, then plt dot title, you can say model loss, then plt dot y label the loss, and plt dot x label box, then plt dot legend, train show. So as you can see the graph of that, this is a training and this is the testing loss, how much we lost. Okay, so it's quite okay. So now let's see for the accuracy one. plt dot plot history dot history accuracy. Okay, then plt dot plot history dot history, then validation accuracy, plt dot title, then model accuracy, and plt dot y label. Y label should be like accuracy. plt dot x label will be approx. Then plt dot legend, then I will train comma test, then plt dot show. So you can see the accuracy. This is the accuracy of the training and this is for the testing. It's quite okay. So now let's recreate the exact same model including its weights and the optimizer. Then we will see the summary, then again we will do the epochs. Okay, model fitting for the better accuracy. Okay, so for recreating the model I will write here new model equals to tf dot keras dot models dot load model Kaggle working dot h5, then new model summary. Okay, so now what I will do, I will run again new model dot fit x train comma y train comma epochs comma batch size equals to batch size comma validation data equals to x test comma y test. Okay, model dot fit batch size, new model dot fit x train y train epochs this time I think we'll get the good accuracy. Okay, after that we can predict. So again this will run till 10. 1 2 3 4 5 6 7 8 9 10. Okay, if you have any doubt till here you can please comment down below. Okay, if you have any queries related to Python, machine learning, or don't forget to check the course link. It will go till 10. Or if you want this full code, just comment down below for the same. I will provide you the drive link. Five more left. As you can see here, accuracy is increasing, okay, with the new model. Okay, two more left. The accuracy is OP, like 99%. Okay. After this, we will save the model and visualize the prediction on the validation set. Okay, so now let's save the model. Okay, so now we will visualize the prediction on the validation set. That I will write the code and get back to you. Okay, so here now we are doing, we are storing some properly as well as the misclassified indexes. Okay, so here is like the proper classes, that is misclassified classes. Okay, and here we are loading the model predicting. So let me run it. Still 40. Okay, so let's see the correctly classified flower images. Okay, for that I will write warnings dot filter warning. Always. Then warnings dot filter warning. Then ignore. Then count equals to 0. Then figure comma ax equals to plt dot subplots 4 comma 2. Then figure set size inches 15 comma 15. for I in range for j in range 2. So let me write that code. Okay, unindent does not match. Okay, bonding spelling is wrong. Okay, figure dot. Okay, let me debug the error and get back to you. So as you can see, it's run properly. Okay, see, predicted flower daisy and actual flower is also daisy. Predicted flower sunflower. Okay, the photos are not, high quality, so that's why here you can see the rose is seeing the rose actual. Okay, this rose and dandelion one, then the daisy sunflower. So now what we will do see like some of the flowers which are misclassified. Okay, the same code will be there. Okay, I will write here. Let's run this. So these are some, the actual flower was tulip but predicted rose, so these are some misclassified images. So I hope you understand till here. Okay, this is the how you can do flower recognition using deep learning with Python. If you have any queries related to Python machine learning, you can comment down below. Okay, so thank you for watching this video. Till then, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.